All right, we've got a video for 6.1. So first of all, we have a probability model, and a probability model is when they tell you the values of all the values that x can take, and the likelihood or the probability that those things will happen. All right, so step one is going to be proving or showing that this is a legit probability model, and to show that, each probability needs to be between 0 and 1, and the sum of all of those probabilities, however many there are, needs to add up to be 1 exactly. And this, I'll make a reference to this, but we don't actually need this graph here. But I would like to point out this graph is skewed right. And we'll come back to that in a minute. All right. Now, something that we're going to have to get used to starting in chapter 6. So technically, it should have been in chapter 1, but we didn't because it's just too many steps to learn at that point. But you have to define the variable. So we're going to have to start giving a variable, and then we're going to have to just start defining it with context. And you're definitely going to want to be mindful of making sure that that variable is in context, full context. Then this one is, what's the difference between at least and more than? And at least means you include that value, more than means you don't. Also, just make sure on this problem right here that, you got to write the inequality symbol correctly. You wouldn't have to write at least here. This is just a little note of it, but you have to put the value both by work in the answer and on the probability statement. It must be written down correctly. Also, because we'll do normal CDF again this unit, and when we do these problems, a lot of students try to do normal CDF, but this distribution is not normal. So no normal CDF for this problem. All right, the next one is about a corner bet in the gambling game of roulette, which is the ball where they spin the ball and it lands on one of the numbers. And a corner bet is made. There's 4 outcomes that are winners, and you win $8, and there are 34 outcomes that are losers. So on a corner bet, you're covering 4 of the numbers. So there's 4 winning combinations and 34 losing combinations. So what is the net gain over a large period of time, or what is the average gain per spin? So we either lose $1 34 of 38 times, or we win 4 of 38, and you multiply those together, add them up, and it's negative 5 cents. So the average net gain for the player is a loss of 5 cents per game. And here it says it's a loss of 5 cents for the player, a gain for the house, but because this is written as a negative as the player's average gain, we definitely want to be negative, and it would be a loss of 5 cents. Over the course of many corner bets, Vegas wins 5 cents in each one of those over time. That's actually quite a bit of money because there's a lot of corner bets that are made. Anyway, the equation for figuring that out is we take the 2 pieces, the number plus its probability, multiply it together, and then we do that for each of them, add them all up. This is what it looks like in a formula. So the first value times its probability plus the second value times its probability plus the third and fourth and fifth and sixth and so on. This is the template for interpreting a mean, and you can go ahead and write that down. I'm not going to spend a lot of time with that in the notes. You can always pause it and write it, but then here, this one is going back to the question at the beginning with the number of languages spoken. So to find the mean, we have 1 language in 63% of the people, 2 languages in 29.5, and then multiply those all up and add them up, and there it is. All right, and then the interpretation is, if we randomly select many U.S. high school students, the average number of languages spoken would be about 1.457. So if we do a large number of random selections from that group, the average, and that's average this time, the average, whatever it is we're looking for, will be about, and then whatever the mean is equal to. On this one, does expected value have to be equal to one of the values? No, so we got 1.475. That is not one of the actual values. As a matter of fact, if you force it by rounding it to it, they will take points off. So try not to round those to whole numbered answers. Oh yeah, by the way, just throw this out on the, I'm going to try to rescan these, but this said languages, which is an error on the notes that we did in class. But like I said, I'm going to rescan before I send these out. All right, so standard deviation of a discrete random variable is, again, here's a big messy equation. Here's the template. You can pause it and copy that down if you want. If you're taking your notes, or that should be already written on there. And I'm actually going to skip this red. Well, I'm not going to talk about this one on the notes. We're just going to use the corner bet. So for the standard deviation, what we do is we take the value, we subtract the mean and square it to get it to variance, so then I can combine together. And then I square root that whole big mess, but then times the probability. So the value minus the mean squared times the probability that happens. The other value minus the mean squared times the probability it happens, and so on. So on this one, we had either lost $1, sorry, so we're skipping that one, point to this one. We either lost $1 or we get $8. Okay, we lose $1 on 34 out of 38, but it's $1 loss minus, but remember it was negative 5 cents. So that's turns into double negative, turns into plus. And then there's what we get. All right, so now I'm going to show you on the calculator. And I already went ahead and pre-typed these in, but I'm going to put the languages spoken as L1 and the probability that they happen in L2. Then I'm going to hit stat calc 1, and then I need frequency list to be L2. That will not be factory. This will be L1 factory preset. This one you will need to add in L2. So if I cleared out, you just hit second 2, and you get L2 there. And then mu or X bar. It's mu, but the TI calls it X bar, but they can call it whatever they want. But that's the average of the expected value, weighted value, whatever you want to call it. And there's sigma, there's the standard deviation. So that's how I get those two numbers right there, okay? And then I can get variance by taking my standard deviation and squaring it. All right, and then this is just a practice problem, although I don't have the interpretations on there. This is also not on your notes, but there's the table. You can plug that in, just like we plugged in the last problem. And then you're gonna get 1.1 for the mean and 0.943. And so then you just go back in and fill in, you actually get the answer on the calculator, then you backfill in the work. And it's this times this times this times this, one at a time. And then for the standard deviation, it's the same value, 0, but you subtract the mean, which was the answer from this one. And notice we do minus 1.1 on all of those. So you take the value 0, 1, 2, and 3, minus the mean, minus the mean, minus the mean, square it to turn it to variance, then I can add them together, but you also need to multiply it by the probability that it happens. But you backfill in the work. All right, and then we have continuous random variables. So this is a continuous random variable instead of a discrete random variable. I'm not gonna really talk about this too much because you can just write it down. It doesn't really seem to help explain it too much, but here's the problem that we need to make sure we're ready for. So this one, it says the weight of 3-year-old females is normally distributed with a mean of 30.7 and a standard deviation of 3.6. So on this one, they're just telling us what the mean and standard deviation. It's not a table. This is a continuous random variable problem. Find the probability that a randomly selected 3-year-old female weighs at least 30 pounds. All right, so first, here we go. I have to define what my variable x is. Then I have to state the distribution of x, and I'm going to say that it's normal with the mean of 30.7, standard deviation of 3.6. Then what's the probability that x, a randomly selected female, 3-year-old female, weighs more than 30 pounds? Make sure that's written correctly. And then it says normal D CDF. It should just be normal CDF. I don't know why I have a D in there, but we got rid of it there. And then answer the question in a sentence. And then these are just a couple more follow-ups. This one, it's in between two values, so we get our lower upper. We don't even have to put like 1,000 or 0 in for the lower upper. And then the last one is, what value of k makes it so that 80% of the values will be, x will be less than k at 80% of the values. So this one, I know the percentage. Okay, when I know the percentage, that's inverse norm. So just a refresh on how that can work out. Anyway, there's your first video, under 10 minutes. Pretty awesome.